Hi, my name is Josh. Today I'm going to show you guys a quick tutorial on how to use a micrometer to make precise measurements of parts up to 1 inch. So before I get started describing how to read the micrometer, we'll go over a couple of the names for the pieces of the micrometer. So the main body, seen here, is the frame. The anvil is the part that touches the part but does not move. The spindle is the part of this which rotates and actually moves to make the measurement. The sleeve contains all of your numbers that you're going to read. It has 3 different scales on it. One for 10,000ths of an inch, one for thousandths of an inch, and one for hundredths of an inch. And we'll go over those later. This particular one is actually a vernier caliper, sorry. It can actually measure in the 10,000ths of an inch. And the vernier scale is right here on the top, as you can see. And one more thing to note, when you're measuring your part, in order to ensure consistent measurements, the thimble, which is the part I'm spinning right now with the knurls on it, actually will rotate freely like that once the part is clamped in place. And this ensures, like I said, a constant torque on this so that your readings aren't affected by the flexing of the frame. And also, one more part is the lock right here. This will lock the spindle in place so that it can't rotate. So, for example, you would measure your part, lock it, and remove it to make the reading. So, now let's go ahead and measure some things and show you exactly how this works. We've got this little piece of angle aluminum here. We're just going to go ahead and try and measure the thickness of here. So, we've got the micrometer open up enough that the piece of metal floats freely in there. Sorry. What we're going to do is we're going to go ahead and spin the thimble. Until it doesn't spin any further. And that's exactly where we want to be right now. So, you can see right here on the main body of the micrometer, you can see a 1. This is the tenths of an inch. So we know that this piece is at least 0.1 inches, or 1/10 of an inch. So, and we also notice that on the thimble part, you can see here that it is not reading 0. So we know it's slightly more than 0.1 inch. So we have to continue reading some numbers. So the numbers on here, I'm going to go ahead and open this up so you can see all the numbers here. Notice there's a 20, and then it goes back down to 0. So these are in quarters of 100th of an inch. So that is 1 full revolution, which is 25 of these tick marks, corresponds to 0.025 inches. So 4 full revolutions of this will give us 1/10 of an inch. Now that can be kind of confusing, but you can see the 4 tick marks in between the 0 and the 1 here. Those indicate 1 full rotation each. So you can see here, if I undo this a little further, you can see that tick mark right after the 1. Well, when we're fully clamped on this, we don't see that tick mark yet. So we know that it's between 0.1 and 0.125. So, if you look here, the line right above the 0 and the 1 reading, as you can see by the arrow, is where you read this, the numbers on the side here. So you can see here that it's reading 15, and then looks like 16, 17, and then some amount. So we know that this is 0.117 something. We don't know the next number yet because we haven't read it. Now, let's say that instead we are slightly past this 0.25. Then we're going to have to do a little bit of math here. So let's say we're floating right about here. So that's 0.125 plus some amount. And that some amount you can see right here, we're right on the 10. So we have 0.125 plus .010. So you have to do a little bit of math. You just have to be careful. But luckily, this piece, we're not going to have to do any math with this one. So again, right now we are at what was it that I said? 0.117. All right. So then we have one more measurement to read. Let me flip this around, take these pins out of here. This is the vernier part, which will get us the 10,000ths of an inch. Now this part is a little tricky. So you can see that goes all the way from 1 right there on that side to 0 on this side. So this scale is totally irrelevant to the previous ones you have read. So what we're looking for is for one of these lines to match up to one of the other lines. And it looks like 3 is a pretty good candidate for this one. So what that means is that is 3 10,000ths of an inch. So what we read is 0.1 right there, 0.017 from that scale, and then 0.0003 according to where that lines up there. So our final reading would be 0.1173 inches. Now, that 10,000ths of an inch can, surprisingly or not, change with temperature. So, you know, that could be critical, or you could really not even care. But you will notice if you, for example, go sit this outside on a hot day, it'll read a different value than if you use it on an ice cold day outside. But since inside is usually about the same temperature, you don't really have to worry about too much. So let me show you a little bit more detail on this vernier part here. Take that out. So let's just rotate it, something random here. So let's say we're reading this measurement. Okay, that's a bad one because I just did the exact same thing we just did. All right, so spin it to that point. So you look around to find where that line as closely as possible matches, and it looks like 7 is a pretty good candidate. It might not quite be 7, but this reading would be whatever the other readings tell us. Well, I guess we can just make this full reading. So we're slightly past the 2, so that's 0.2, and then we're just after the 18 on the next scale here. You can see here, just slightly past the 18. So that is 0.218. And we look on here, and the closest match on the top here is 7. So that's 0.2187 is how you would read that.